Now, our last presentation, Dr. Aris Georgakakos. Dr. Georgakakos has got PhD from MIT in water resources, and he is a professor at Georgia Tech School of Civil and Environmental Engineering. He is also the director of the Water Resources Institute. Please, Dr. Aris. Dr. Aris is well known for his work in the Nile Basin, and he's going to present today impacts of climate change in the Blue Nile. Yes, please.
It's almost afternoon, so good afternoon to everybody. It was very nice to sit and listen to our previous speakers. And I'm also very... doesn't work? Hello? Okay, maybe now it's better. Okay, that's better. So I'd like to thank the ministry, Dr. Iman, but also the Minister of Water for inviting me to participate in the conference. This is the second conference. I was here last time too. I had the keynote address and I had more time. Now Dr. Mohammed says I have to finish in 15 minutes, so especially because we have lunch afterwards. I'd like to acknowledge my co-author, Hussein El Sharif. He is a postdoctoral student and research associate now at Georgia Tech. And he has received recently his PhD with me in agricultural planning and climate change. You know when they say that senior professors have a brain trust behind them? The phrase has been invented for Hussein. So in my previous talk, we went through and explained and discussed some previous study we did the last 4 or 5 years on the sensitivity of the GRD and the impacts that it might have on the countries of the Eastern Nile, Ethiopia, Sudan, and Egypt, of course. And it was a detailed study. We developed a very detailed modeling system that took into account all the existing facilities and water uses, especially in the water sector, the energy sector, and agriculture. And it reached some important conclusions, which I just quickly want to review because this one is the second installment, is about something that we had not addressed in the previous study. So we looked into the dam filling issues, and we concluded that there are many different rules that one can apply to fill a dam, but in this one in particular, because of the large storage that it may have, we need to be a little careful because fixed year filling rules, whereby no matter what we decide to fill the reservoir to a certain level, might be associated with significant harm and damage to the downstream countries if they happen to coincide with drought. So instead, we suggested that perhaps we should link these filling rules to the yield of the Nile, how much water is coming in. If the year is wet, then perhaps more water can be stored into the GRD and without any real harm to anybody. And then we also studied very extensively, in collaboration with the Nile sector in Egypt, the question of what potential regulation strategies could be applied to the dam. We looked at independent, nationally focused operation, but we also looked at cooperative strategies for regulation of the dam, and we demonstrated that it is an asset. We were very optimistic in our conclusions. We found in the end that a project of that magnitude, if it is coordinated and in a cooperative way with the existing assets in the region, the Hydrologic Dam and also the Sudanese reservoirs, Osiris and a few others that are coming online, can be a significant asset for the region as a whole. But it has to be done in a coordinated, cooperative way. And we had outlined some of the principles and rules. And Some of them were to make sure that we have a well thought out drought management plan, because droughts are going to be, and this was mentioned earlier by others as well, are going to be the main issue here in the construction of the dam. It's going to change completely the flow of and the pattern of the Nile as we know it. This seasonality is going to go away, and it will create opportunities, but also it may have, if not managed properly, some adverse impacts. So we thought that perhaps a more detailed, a more well thought out plan, as I said, for droughts is really appropriate for the treaty that is being negotiated and promulgated. We talked about a monitoring program because our WMO colleague made an excellent point about the need and the value of data. Data are only important if they're used, especially for purposes like this, to regulate and to manage and to cooperate. And so a monitoring plan where the data is shared among the countries of the Nile is very important and critical. We do a lot of that here in the Eastern Nile, but I think more can be done. And so a more comprehensive monitoring program, and to support the tools and decision systems that are needed for the adaptive and proactive regulation of the dams is very critical. You see, once you put a dam like that, GRD, at the headwaters of the basin, you have to cooperate with the downstream folks, because whatever releases are made at the GRD are going to impact the rest of especially the Sudanese reservoirs that are small and can fluctuate very quickly, but also the highest one dam. So cooperation to me is something that has to happen, and it starts with the sharing of the data and also the sharing of decision tools, the forecasts that are issued, and also the strategies that need to be applied to make sure that everybody gets what they need from this. And the last bullet here was about the climate change. You see, all the work we've done, and ourselves and also others, in the basin, I think focused on one of the significant flow data that we have for the Nile for the last 100 years. The issue, though, is that the climate, unfortunately, is not going to cooperate. It's going to change. And so we need to have a very detailed analysis and understanding of what the climate change might mean for this region and for the treaty itself. So this presentation is about this. We have spent some time the last year in our free time, actually, because we didn't have any resources to dedicate a significant time on it. But we have spent some time trying to understand what climate change means, and I'd like to present to you some results and draw some lessons for the treaty that is being negotiated. So we have done this in several places in Africa and also the US. And I typically start with a set of questions that we would like to get answers to. And the first thing is that, is it real? Is there evidence? Just because we have cartoons that talk to us about climate change doesn't mean that it's real locally. And what is it really? I mean, how do we quantify climate change? And what does it really mean for the goals that we have to manage water resources in this region? It could be beneficial, it could be impactful, it could be risky, it could be an opportunity. What is it? So I especially like to look into observed historical data because it's convincing. If you look at historical data, and it's nothing to do with opinions of people that you may not actually know or trust, and demonstrate that there is evidence of climatic change in the historical climate, then I think you begin to realize that there's something that we need to address. So that's the first one. Second one, if there is evidence of climatic change in the data, and therefore something that you have to address in your water management initiative, the question is, how about the future? Can we actually distill any good information from all the good science of the climate scientists that give us all the GCMs and the IPCC folks? Can we distill some good information that we can use, that is usable, actually, has a narrow uncertainty that is useful for engineering and scientific applications and water resources impact especially. So that's the second thing, about the future and about whether atmospheric processes are going to change in a significant way. So the next level down in a study like this would be, what are the hydrologic impacts? Just because the climate changes a little bit, or in some significant way, it doesn't mean that the flows are going to change. It doesn't mean that the soil moisture is going to change. It doesn't mean that the aquifers are going to change. So the hydrological variables, which is something that we really depend on for our purposes and the water uses, need to be assessed. So there is the second level of assessment. First is atmospheric forcing, and secondly is hydrological changes. And the third is the question of water resources. Because again, hydrology might change, but if we have a large dam, this might not be so significant. Or what is the time window that this buys us if we have a large dam? So there is a third level of assessment that has to do with the water resources network, the infrastructure we have, or the planned infrastructure, or the strategies we are thinking and contemplating to apply to try to mitigate climate change, if there is one. So, these three levels of assessment that need to be done, and the atmosphere, the climate, climatic variables, hydrological variables, and then the water resources impacts. And finally, if you do this right, and you burn the midnight oil, you need to figure out of this information what is possible. What are the options we have for good adaptation? Okay. So one thing I'd like to say at the bottom there is that this is not an easy and a straightforward process. This is not for the faint-hearted. You need to have trained people who understand how to go from and complete each step in sequence, and also draw the conclusions that are necessary. I have come to see situations that I work for one ministry, not here, but in some other country, and we came up with conclusions about climate change, and then some other consultant from somewhere in the world came into another ministry, and then they said the exact opposite. So I said, water is going to dwindle a bit, significantly actually, and therefore you got to stop investing in hydropower projects or in projects that actually in agricultural expansion. The other fellow said, plenty of water. Don't worry about anything. Let's move ahead and build the heck out of whatever resources we have. It cannot be that climate change means two different things for the same government, the same peoples, the same agencies. So it's not a standardized procedure, and I think the understanding and the technical expertise has not penetrated in the private sector. So I've seen ways to address or try to do studies of climate change that I would not even sign off on a master's thesis or a homework for my students. So we have to be careful, and that's actually an area that we need to improve. We need to educate people how to do this and to standardize the procedures and have metrics that indicate how this should be done. So let me tell you about the Blue Nile and what we did to try and understand what climate change means for the Blue Nile Basin and the effect it will have on the Eastern Nile countries. So this is the basin, the Blue Nile Basin, comprised of 5 sub-basins: Sistana, Khartoum, Bil Medaya, and GRD. And we have listed here the elevations and also the areas that each one has. The first thing to do was to try to see, do we have climatic evidence of change in the observed data? So we looked at various climatic variables like temperature, precipitation, potential evapotranspiration, and precipitation deficit. I don't know if you can see the graphs so well, but there's clear evidence of change. And if you, especially the top graph shows the temperature sequences, the averages on the different sub-basins of the Blue Nile, the 5 that I mentioned. Of course, because of the elevational change, they have different mean levels that they vary. But all of them actually, especially after 1980, 1970, 1980, experience and exhibit an upward trend. And to the tune of maybe 1 to 1.5 degrees Celsius from 1970. The precipitation doesn't change as much, I must say. And it's fairly stable, or it decreases slightly. And the PET, which is the capacity of the atmosphere to abstract water from the land and also from the water resources, the surface of water, and also the soil and through the plants, is also increasing because that's it has a strong dependence on temperature. So if the temperature goes up, PET, the capacity to extract water, is going to increase as well. And it also goes up quite significantly. And finally, the deficit, which is the precipitation minus the PT, for a particular basin goes down because if the precipitation stays stable and fluctuates in a stable way and PT increases, then the deficit is going to increase, actually, which is bad news because, you know, it's that when the deficit decreases or increases, we don't have enough water for our water uses. The soil gets a little bit depleted. The flows might be depleted as well. And so that's about the atmospheric variables, the climatic variables. And the next level that I was telling you about was about the flows. And if you plot, and if you have the Blue Nile flow at border or at DM, as we did for a number of years, you can see that in the long term, it experiences a decline, slight decline, but a decline. So this is consistent with what I just told you about the temperature increase, the PT increase, and the stable precipitation or slightly decreasing precipitation. So I don't think there is a doubt that we have some climatic change going on. And of course, the real question is how will it evolve? What will happen to it in the future? And how it will affect, potentially, the countries that share the Nile waters. Because the Blue Nile is a significant contributor to the main Nile flow to the tune of maybe 2/3 on an annual basis or more, occasionally, depending on the floods. So how do we look into this? How can we distill, as I said, some information from the current science to try to figure out if we have something to worry about, but in a quantitative way? The way we do it is with these three stages. The first one is to choose what kind of an emission scenario, greenhouse gas emission scenario, we need to look at. There are different scenarios because they are called scenarios. They're not called predictions because they all depend on what the societies of the world are going to decide to do about climate change. Will they reduce the emissions? Or they are going to sort of come to a compromising solution whereby we can curb the greenhouse concentration in the atmosphere and therefore give a chance to the planet to breathe and recover. There are different scenarios of emissions. Some of them indicate intensive emissions and more aggressive industrialization without much concern about the environmental sustainability. That's the scenario RCP 8.5, which is the red one in the top graph. And then there are other scenarios that are milder, and they sort of imply cooperation among the countries of the world, especially the industrialized ones. It turns out, given the recent IPCC reports and also the assessments we've done in the United States, that unfortunately we're following a path that's consistent with this aggressive emission scenario. So the RCP 8.5, I would say, is more of a likely path that we're following at present. We typically do this analysis that I will tell you for all of the emission scenarios, especially two. They want to bracket at least the uncertainty that we might expect. But in this case, we didn't have time to do it yet. So I'll show you results for the 8.5 emission scenario. So once you decide on the greenhouse gas emission scenario, the next thing to do is to try to extract the information from the GCMs, the general circulation models that are run by global international organizations. And what they do is they sort of canvas the planet with numerical models. They are quite significant models to run, and there's a whole staff that has to operate them. And so these projections of this scenario, of these models come from these models. There are many of them, and the best way to acquire these projections, these raw projections, are from the IPCC, and we typically use all the publicly available models. So we don't just look at one or two. It's tempting because it's a lot of work to do all of them. But the good thing is, if you were to look at all of them, or a significant number, you can understand the climatic uncertainty of the models. So it's a good idea, despite the overhead of work, to actually look at the ensemble of projections and what they mean. So that's what I'll show you in a second. So after this thing is done, and we collect those GCM projections, the next thing to do is to try to understand what they mean and to decipher the information they have. That's not that simple as it sounds, Okay, it's not that you can take a model that somebody has vetted, and you got to work with those models because they have biases. So that's what the last bullet says. It's about bias correction of GCM projections. Let me show you what I mean. So these are 4 models actually, and then on the top 2 panels, I have precipitation climatologies from the models versus for the same historical horizon as the observed climate. So the black lines correspond to the observed climate, yes, and temperature and precipitation, monthly temperature precipitation, and the red lines correspond to what the models say for the same historical period is happening. So we averaged by month, whatever the scenarios say, and these are the results. So you see, if you look at the precipitation part, some of these models actually provide excess precipitation, too much precipitation that doesn't exist. Imagine if you were trying to do a hydrologic model with these results. You would say, actually, we have so much water, my God, we're going to start exporting water everywhere. But that's fictitious. It's not real. So we need to bias correct these models. And the same thing for temperature and other climatic variables. So bias correction, which has not been mentioned yet in these talks so far, it's a very important aspect, and it's part and parcel of the analysis we do for the GCM projections. If we don't do this right, you run a risk of and this is what happened to that little occasion I told you with this other country, where that consultant from an unnamed country decided that we have plenty of water, and therefore let's go ahead and invest billions of dollars in hydropower stations. So it's an important thing to do this. There are common pitfalls how bias correction should be made, and there are many things that people who sort of are trying and want to get in, especially the private sector engineers who have not had exposure or understanding of climatic change and concomitant techniques. There are so many things that people do that make no sense technically, and I have listed a few here. But one of the things that I'd like to, and one message I'd like to tell you is that first we need to use an ensemble of scenarios. We have to do this from many scenarios. Just taking one model and doing this is not enough, okay, because you underestimate significantly the uncertainty of the future projections. So that's one. The second thing is that we need to jointly bias correct their climatic variables. You cannot just take temperatures and say, I'm going to find a technique to try to match it to the historical data. Yes, you can do that if your application only requires temperature. And you can do the same thing for precipitation if your application only needs precipitation. But in hydrology and water resources, we typically need both or more than just 2 climatic fields. So you cannot just do that separately because these variables are connected. So if you do it independently, again, you underestimate the uncertainty of the joint field. So we have developed techniques called joint variable bias correction, which I'm not going to go through, but this is what we use. So let me show you some results for the Blue Nile Basin, because Dr. Mohammed here needs to finish the session. So this is how the results look after the bias correction for 2 periods. The middle period, okay, the first period is the historical period from 1985 to 2003. So all of these 3 periods, you have 20 years length each. The second one is from 2030 to 2049, another 20 years. And the last one is towards the end of the century, from 2070 to 2089. So the lines that you see, this comes from one GCM. This is, I call it GCM1. There are specific names, of course, and other things that you can see. But the lines you see here have to do with the corresponding temperature sequences that are expected after bias correction and for each one of the subbasins. There are 5 of them, and the thicker lines correspond to the average for the Nile, for the Blue Nile Basin. So it's clear that temperature increases not only in each one of the subbasins, but also on average for the whole of the Blue Nile Basin. Different basins have different characteristics, okay? And they experience different trends. But the message here is that all of them are going to increase to the tune of maybe 2 to 3 degrees Celsius by the middle of the century, and maybe 3 to 4 degrees at the end of the century, or towards 2099. The precipitation, on the other hand, in the lower chart for this particular GCM does not change much. It fluctuates, and you can say that, yes, it changes a little bit, but it fluctuates and it doesn't move very much. In this particular GCM, which is the second of the 24 that we use, there is a little bit more of a change in precipitation. So it may be that precipitation increases a little bit, but overall, this picture is typical of all the 24 GCMs that we have bias corrected. We do a lot of manipulation of this data to try to understand what they mean for each one of the subbasins. For example, there is graphs like this of temperature, precipitation for all of the 24. You see, I just showed you previously 1 and 2 GCMs, but here we have put together all of the GCMs and what they mean for each subbasin. So again, the same picture emerges. Temperature increases, precipitation stays constant or slightly decreases. And this is the same thing for all of the basins of the Blue Nile. So, so that's the climatic assessment. If you notice, the reason I said that we need to use more than just one GCM. And the reason is because all of them are legitimate. They parameterize the processes a little differently. But if you don't use them all, you really reduce a lot the range of the uncertainty that of the projections imply. So that's why if you really want to have a good sense of how the climate is going to vary, it's good to have an ensemble of these projections as I showed you. So this is the climatic change. And we have quantified it through sequences and also with statistics that you can, whatever you like to see. Averages, lengths of drought, of precipitation deficits, whatever you want to do, you can actually extract from this data because they're actual numbers and sequences that we can work with. So what do they imply for the Blue Nile? Flows. Well, the flows are hydrologic processes, and what happens is they are impacted by changes on the water cycle. So if this is, for example, the historical water cycle that used to operate in the basin for years, before, and this corresponds to climate change. And if you notice, what I did was I increased the evapotranspiration because the temperature increased, and therefore, so you expect to see some reduction of the flows. So the stream flow errors and also the errors in soil moisture, the recharge of aquifers are really becoming thinner because of this. This is what the trend is for the Blue Nile Basin. But the question is, it's a nice cartoon just to get people to understand, but the issue is, what is the quantitative picture that we can draw from this? So the way to do this is to use physically based hydrologic models. We have to calibrate. We cannot just simply do some association or regression between the future and the flows based on the past, because if you do that, you basically undermine the premise of using climate models and the premise that the climate will change. So what needs to be done in this case is to calibrate well a physically based hydrologic model that replicates the hydrological processes that operate within the watershed. So we've done that. And here's the result. It's a two-tank model, a Sacramento-based model with some innovative ways to calibrate these parameters. And so we have done this for the Blue Nile Basin. I'll show you some results. So this is the calibration and verification period from 1966 to 2011, for which we had data, both precipitation, potential evapotranspiration, as well as flows. It works satisfactorily, I would say. The lower graph at the very bottom shows the climatology of the model and the climatology of the real flows. And they pretty much coincide. You don't have these discrepancies that we saw earlier for the raw atmosphere data. The one piece of information from the calibration of the model is that the runoff coefficient, the long-term runoff coefficient, which tells us how much water from precipitation actually becomes stream flow in this basin in the long term, is about 21%. So 21% of the rainfall that falls on the Blue Nile Basin becomes stream flow. The rest of it actually in the long term becomes evapotranspiration. It goes back in the atmosphere. But in the meantime, it actually uses, is absorbed by the storage, the soil moisture storage, which fluctuates depending on the season, and makes possible the flows that are observed. I say that because there's a lot of discussion from water resources folks that water is plenty in Ethiopia, and therefore they could use more of that as opposed to the flows in the river. But the system doesn't work this way. I mean, we have to understand how the system works in terms of how the drainage and the releases of the flows are supported by the soil moisture, okay? And then we can begin to have a better sense of what kinds of measures might be appropriate. So with this model, what we did then is to drive it through the climatic sequences that I mentioned to you from the bias-corrected GCM data. And this is what the results show for the first future period for the flow of the Blue Nile, okay? And the second period, sorry. So the top graph shows is the flows of the Blue Nile at DM projected for the first climatic period, 2030 to 2049. And the second one, the lower graph, shows the ensemble of the flows that are expected towards the end of the century. Well, there's a deficit. There's a decline, and that's the ominous problem we have here. And so from 45 BCM, which is the historical average, and it corresponds here to the red line that I have put in just to see how the ensemble is placed with respect to the historical data. From 45 BCM, that is the long-term historical average, at least 1966 to 2011, but earlier too, the mean annual yield becomes 38. So there's a 16% reduction that's projected for the first climatic period. For the second climatic period, from 2070 to 2089, because the temperature increases significantly, the reduction is more severe. It doubles. It becomes, the annual average is 29 BCM, and that's a 36% reduction with respect to the current conditions. These are important results that actually tell us a lot about what we need to worry about with this treaty that that the countries are about to sign off on. As someone said from the previous speakers, you cannot look in the past. Here, we have a serious problem that has not been addressed in the assessments and the negotiations and discussions about the treaty terms. So what do they say? And this is the last slide, Mohammed. I'd like to give you the conclusion that climate change it's going to usher in a new risk, a foreboding new risk for the Eastern Nile countries, both nationally, but also with respect to the transboundary water management. On the positive side, and an optimistic side, if the GRD storage is established, it becomes an asset. And storage and gives us the ability to transfer water and to distribute water more evenly, and therefore meet some of the needs that the countries have. So in the face of it, it can be a significant asset with respect to climate change because it can actually mitigate the adverse impacts of all the partner countries. But there's a caveat in this, and the caveat is that it has to be operated in a cooperative way with the other storage assets we have in the region, in Egypt and Sudan. Otherwise, it can become sort of a standalone, and perhaps it can benefit one country, but actually can create more conflicts that can lead to military confrontations. And that also brings everybody in the loop. So from the climate change standpoint, I think two messages. GRD is a good thing, the storage, especially because it's in an area where the evaporation is not as high. But the second thing is that the climate change creates an imperative for cooperation. One project individually, that is, if you were to operate the dams we have here on a national basis without cooperation, the results are going to be much worse than if you were to cooperate. And that, I believe, is a good incentive and motivation for the countries to cooperate. And the third bullet here says that in developing a treaty like this, in view of the uncertainties of the climate and in the projections I made, I just described, I think we have to actually focus on a flexible treaty without really thinking about very unwieldy thresholds of flow quotas that we have to communicate year after year after year and commit to them. There's no such thing. The climate is going to undermine all of these thresholds that we all think about. But it's better to focus on principles of adaptive management, principles of equitable sharing of the gains, but also of the shortages and of the damages that these shortages actually are going to accrue to everybody. And finally, the last bullet is that I think we need to inform the folks, the policymakers, who very diligently work on the promulgation of the treaty about the issues of climate change. We are at a very precarious time. Looking only at the past is really doing the same thing that everybody says we should not be doing. Let us use the best of science we have and figure out a way to actually create solutions and invent solutions that actually make sense for the region. And I'll leave you with this quote because it was done by Wells, who was just a futuristic fiction writer. It's actually long ago, but I think it makes a very important point. The only hope we have, and my bet is on education, both of the technical people and the creation of human resources that can invent these solutions and understand the details, because the devil is in the details, no matter what your faith is. But also of the public, because I think we all have to change our mindset and realize that sustainability and the existence of our societies depend on this education and understanding. Thank you.
Thanks so much. Thanks a lot. Very interesting presentation. And I think you agree with me. We have very interesting presentations. Now it's time for the audience. We've got like 20 minutes. For questions? Okay.
Thank you for all the speakers. I have a couple of comments and questions for Aris and for Henk. Aris, correct me if I'm wrong, and with all the respect, my understanding for the RCPs that we have 4 RCPs, RCP 2.4, 4.5, 6.8, and 8.5. And those RCPs, like those numbers, stands for the specific heat capacity which will be stored in our climate system. And they correspond to how much CO2, how much greenhouse gases are being put in our climate, ranging from 400 parts per million all the way to the scenario that you used, 8.5, I think around 900 plus parts per million. And those corresponds to, by the end of the century, by 2100, into specific temperatures anomalies that are going to be increasing. What you presented was the 8.5 scenario, and you said in the climate part, it's going to result in 2 to 4 degrees by the end of the scenario. But according to my knowledge, and correct me if I'm wrong, it results in 7 to 8 degrees increase by the end of the century. It's not 2 to 4. The 2 to 4 is the scenario which is the RCP, I believe 4.5. And that's why the 1.5 degree scenario came out by the IPCC last year. Because the IPCC said if we did not maintain our increase in temperature by 2030, not to exceed 1.5 degree scenario, this is why we are going to reach to the 4 degrees Celsius scenario, or 3 degrees Celsius scenario by the end of the century. So the idea was not to, close or to decrease the 2C threshold, but the idea was to make people aware that if we reach that 1.5 by 2030, which is like 11 years from now, the likelihood that we are going to exceed by far the 2C is there. And we are going to reach the 3 degrees Celsius scenario. So that's my comment for the 1.5. But can you correct me if I'm wrong, please? Yes. My understanding it is 7 degrees, not 2 to 4.
Yeah, what you're talking about is about the global change. Each one of the regions is different. And so, this country up here has different elevation, there's orography, and so the statistics you're talking about has to do with the global expectations. Some of the regions are going to experience higher than what you just mentioned, and others will experience lower. The results I have here, actually, we fall within the range of what we expect for this particular latitude and region. So they're not, but 7 degrees Celsius. I mean, if our bias correction process actually gave us this kind of of a change, I think we would be in huge trouble. So I'm a little bit encouraged that the 2030, 2049 is about 1.5 to 2 degrees, and then towards the end of the century, it's 3 to 4. In the U.S., you know, we get.
But I'm talking global. I'm talking like, you know, this is the scenario which.
Yeah, my thing here is to say that yes, they're global statistics, but are they useful for the region here? Like I said to you, if it was 7 degrees here, the reduction that you will observe in the flows would be huge, and that would cause another kind of worries with respect to what to do with this treaty and what to do with the economies here. So I'm saying
that's the point. So why you did not do that for a scenario like the 6.5? That would have made a lot of more sense to me.
We do that for all of them actually, but we choose 2 of them. We choose a 4.5 scenario, and that one is because by the mid-century it implies that there will be some sort of a curb into the emissions, but the 8.5 does not do that. It continues on. The problem, I chose the 8.5 because the problem is if you hear, it sounds that this is a scenario that is actually materializing in most parts of the world. Unfortunately, it's not. So that's not something that we choose and we can stick with that. It depends on what these countries are going to do. But I'm saying we typically do a bunch of emission scenarios, both at least the 8.5 and the 4.5. We intend to do that too here. It's just that we didn't have time, as we didn't have time to do the water resources detailed exercise. But we hope to do this in cooperation with the ministry and the other countries.
Thank you.
Question there.
Thank you very much. My question is for Dr. Georgakakos. I enjoy the presentation much. I just have a question. How much is the uncertainty of your results about the 1 to 2 degree and the decreasing expectations? Because one thing that's challenging for climate change is correcting the past. And when you're doing that, you're needing a lot of data, record from the Blue Nile regarding temperature and rainfall. And as far as I know, that the record for historical data for Ethiopia is very little, not much. So how much uncertainty in your results?
Yeah. So I have been fortunate to, for many years, to work with all the countries of the Nile. I've been to Ethiopia many times as part of actually UN projects that I had here in the region. And we developed planning tools for all of the countries that they use. And so because of that experience, we have some more information than the casual person would have. The good thing is, you know, the whole point is, the test is, can we actually predict and simulate the Nile flows well? The result I showed you from the model, from the hydrologic model, is actually driving the model with simply the atmospheric data, that is the precipitation, the PET, in the sequences, in the different subbasins, and it's calibrated to simulate the Blue Nile flows. If I saw there that the discrepancies are 100, 200% in the flows, then I would tell you that you know, we definitely need to do something about it. But I think that the results are pretty good. They show that there's a more than 90% correlation between the model flows and the observed flows.
Yes, but it depends about how many data that you have. If you have few calibrations with 3 points.
I actually have all the data that you can think about. I do. I don't say that arrogantly.
And of course, this is not shareable, right?
The data that I have received, this initial work was done with the Nile sector. So they were provided by Egypt, but also by our experience with the Nile countries, because at the point that we did the Nile DST project, all the countries had subcontracts to actually derive and obtain data of precipitation, temperature, and all in their territories. So I have this data too. I don't consider that these data are mine. They are data of the countries. So if whoever asks me, can you share this data with me, I refer them to the countries. If the countries give you permission, I'll be happy to give you this information. So, but going back to your main point, I think that there's still a need, a very serious need, to share the data between Ethiopia and Egypt. I mentioned that. The monitoring program, not only of the past, but also of the future, has to be shared. There's no way that you're going to trust what they will say, and they will trust what you say, given limited data. So it's a given. It's the cornerstone of some cooperation.
Well, let me tell you my experience. That we're trying also to do the global certification model for Nile Basin.
Different.
But
I'm hoping that crisis is going to change the mindset of many people.
Let me continue. So we found only the data for climate for meteorological data for Ethiopia is just in the Nile Basin, which is like for like 6 years or something, and the meteorological data there is not well established. They have some like injection by the farmers there or something like that. Yeah. So this is one of the big uncertainty. That's what just saying.
I agree with you, and I fully support that, and I mentioned it, that we need to have sharing of data and models and tools, all verifiable by all parties involved. Otherwise, if you don't do that, I think we are creating more problems than we solve.
Okay, 2 questions there. So, Dr. Shri.
Thank you for your presentation. Shri Zahran from National Water Resource Center. My questions, in addition to the question for Dr. Rami, I would like to ask about how you can select GCM models you are applied in your research. Are you done sensitivity analysis, or what about the regional climate models? Because the topography in Blue Nile need to some downscaling or regionalities for this area, and also if you can share the output for your research in some planning and management model like Nile DST or decision support system for Nile Basin or Basim or something for water planning and management model. And why Sacramento also for hydrological model?
Yeah, so
thank you.
Thank you. All our tools are actually shared with the Nile sector and the Ministry of Water. They have our tools. The Nile DSD and the Eastern Nile tool and model that I presented actually was done for Egypt, but 4 or 5 years ago. So all this information that you're talking about is there. They have it, and it is in their custody to actually to give away if they want. I try to stay on the technical side without expressing opinions about policy. I like to support the policies, and I like to make sure that at least I present the policymakers with options that they may want to consider. Because some of these options actually are not coming out of the general information that we get from the prospectuses and brochures of climate change of the agencies. We have to do the hard work of actually going down into the details of what I presented here, and more than that, especially to figure out what is appropriate and how it should be, this treaty should be constructed. I'm very optimistic because of what I mentioned, but I think that the solutions are going to have to be based on technical hard facts and not just simply on what we did in the past or whatever. You mentioned also about the GCMs. So we use all of them. So to avoid the issue of why are you using one or two, or which one are you picking and cherry picking between the GCMs, we like to use all of them and assess them to see how good they represent the historical climate, and therefore assign weights about the validity and the applicability for a region. But I don't want to throw out anything just unconditionally because it's easy for me to do one. That to me is not professional. And it's not appropriate because it actually constricts the uncertainty that is real, and you just simply ignore it. That doesn't solve your management problem. So yeah, and downscaling, we have experience with regional models, and they all have issues. And so downscaling and also bias correction and downscaling is very, very appropriate. But it's a very technical issue how to do this, and that's what I'd say. It's not for the faint-hearted. It's not that you can actually download from some website a bunch of data that have been quote-unquote downscaled and bias-corrected. You need to figure out if these procedures that these people used, whoever they are, whatever agency they are actually responsive to the goals of your own application. And I don't buy at all the idea that just because it's offered by an agency that has a name that is known, this is necessarily a good data. I have seen discrepancies that are, so I think you need to have someone who understands climatic change, who understands downscaling, bias correction, and a lot of statistics and processes of this sort to make sure that you preserve the factors that are important for your application. For example, let me just give you an example. If you're interested for droughts, multi-year droughts, most of the techniques that are out there do not actually preserve the structure of the interannual droughts. They don't. It's random if you actually get something from the GCMs. You need to actually tell the bias correction procedure and the downscaling procedure to preserve it, to preserve the correlation structure if you're really interested in this. There are subtle points, technical points, that if you don't pay attention, then I think you come up with very optimistic scenarios, which actually are not close to reality. So that's what I'm saying. It's not the idea that techniques like this can actually be used by the public or somebody who comes off the street without technical background understanding of a few years. I think it's absurd. So and can be misleading because they're misapplied. And I have seen that happen. That's why I'm a little passionate about this. I had arguments with some of the private sector companies who very sloppily give recommendations to ministries and energy and water about these issues that are completely unfounded, completely sort of ad hoc and arbitrary. So let us do a good job on this and do diligence on our work to give good advice to our policymakers. And so I'm worried about that, and that's why I say that education, good technical education, is very important. And we're not doing a good job on this, not only here, but also in the US and everywhere. We don't have enough people that can actually do what I'm saying. And we all need to work harder to produce good people to do this.
Thanks. Dr. Dia, please.
Thank you very much, Chair. Wonderful presentations. I like them very much. All of them, actually. This last point we raised, it takes us to the point where do we really need downscaled GCMs, or we develop our own local or regional models? And this is a big issue now. But from the presentation we had, a very good issue is raised, and that is data sharing. And data sharing means that actually nobody owns data, in a way, if we are in a shared river. But now another terminology is used, that is sovereignty. And if somebody is sovereign, then there is no data sharing. And in this case, we have to have a different definition of sovereignty, not as a diplomatic terminology, but as a hydrological terminology in a way. This is number one. Number two, in all what I heard now, where is Sudan? Sudan's position is very critical. The climate in Egypt is better and is good, is relatively good. And the climate in Ethiopia is relatively good. Mm-hmm. But the climate in Sudan is severe, by all means. Sudan is going to be in a catastrophe, I should say, if all we heard here is actually going to happen. Thank you very much.
Shall I say? So, you want to come, please? So do you want to respond to some of the points? Or? Yeah. So the issue of Sudan, I didn't have time to discuss this here. The model that and the assessment we made actually pays a lot of attention to Sudan. One of the conclusions is that you cannot be thinking about Ethiopia and Egypt. This is a truly trilateral agreement that has to be put in place. And we have shown that GRD implies both benefits potentially for Sudan, but also the usage of water by Sudan, which actually has now reached the old levels of 18.5 billion cubic meters or thereabouts. If you count the evaporation from the new reservoirs they have put in, and also the change in the operation, that's going to increase the evaporation by 3 to 4 billion cubic meters a year, because the reservoirs now, Rosiris and Nile and the rest of them, are not going to be fluctuating anymore if GRD is here. There's no point for that because the water is going to be coming very uniformly through the year. So the Sudanese can take much more water. That's why it's essential that Egypt actually comes to an agreement with Sudan. To me, it's even more important for Egypt to actually make sure that the Sudanese come to the table with a concrete plan and a cap on water management. you see, right now, if GRD was not in place, Sudan cannot take significant amounts of water, more than what they do now. They can build a few reservoirs. The terrain is not very conducive for storing water, and so. But the temperature increase have gotten us to a point where we have exceeded the Nile yield. As I have said to the ministry here in these sessions that we talked about, if the drought of the 1980s comes again, Egypt will not be able to sustain. The highest on dam will not be enough. The water usage upstream has increased to a level that you're going to have deficits, and we have estimated quantitatively how many years, what the deficits are going to be. So there is an issue. Egypt is already vulnerable to drought. Now, what I'm showing here about the climate is in addition to this. It's a much more, it's a situation that's why I'm saying Egypt can benefit from GRD, but there has to be cooperation. Without cooperation with Ethiopia and the usage of the storage for all of the benefits of the people, I think we are really having an issue. Your first point is also important, that how do you sort of get people to be on the table? The only way to do this is for them to realize, for all of us here, to realize that we are all connected, and that something that will happen and is going to harm one of the people, one of the countries of the Nile, is going to harm them all. I can see the conflicts erupting to a major military conflict if such deficits actually were to be withdrawn. Yes. And not, so I'm saying that's the incentive, perhaps a negative one, but people, if you want peace and prosperity and economic sustainability, and I think there's no other way, there's no other pathway. If you miss that opportunity, I believe you are making a big mistake. I think you will lose the opportunity for prosperity and economic growth and economic sustainability.
And away from this sort of military actions, they are not on the table right now. But don't forget that we are very much mixed.
Yeah.
Egypt and Sudan is one country, actually.
Yeah.
If Sudan is having troubles,
the solution,
then yeah, a number of Sudanese will be here in Cairo.
Okay, that's exactly the point. You made a very good point.
Because I think we've got
we have to go.
So I will leave the detailed discussions later after the session. Before I move to the next questions, there is a comment here from Dr. Ragab on bias correction.
Do you hear me? I almost have been accused that we didn't take into account the bias corrections. No, we do. But it's a very fine read details, and I avoided, for interest of time, not to mention it. And the reason for the bias correction for us in the UK is that the scenarios that comes from the Hadley Center, based on the baseline data of 1961 to 1990 of the whole UK. And then we have to do a bias correction to the catchment scale. So the fact that I didn't mention the bias correction, it means that we didn't do it. We did it by two methods, and the methods were very close. The other thing I would like also to refer to in GCM's models, that the Hadley Center, they run suite of models, and they select the most close 10 or 12 models for further consideration. The other thing also I would like to add, why we apply the climate change at catchment scale. In my center, we have national scale models like Jules model of the UK Met Office, but this model cannot be calibrated, cannot be validated. So any results will come from a national scale model or large regional scale model results. You have to believe it as if you say, well, I am a doctor, you have to believe me. And for that reason, I prefer always to work on a catchment, because this is the scale. We have measurements, and we do our measurements at catchment scale, and that's the scale we can verify and validate any climate change models. That's just my comments.
And I'd like to echo this because, and that's one of the criticisms that we're facing in the hydrosource that our WMO colleague indicated. A global forecasting model may be doing good things for some sort of a scale, but when it comes down to local flows and local predictions, we got to do, as our colleague here mentioned, that we have to calibrate these models on local conditions. It's not going to be that easy. We have the same issue in the US. There's a national, what they call national water model. It's all poppycock because for the forecast of the atmospheric processes, it can work. But when it comes down to hydrology and it comes down to water resources, you cannot avoid doing this right with respect to what infrastructure we have on the ground, how it's operated, who is using water, at what node, and it's exactly what you mentioned. So I agree with you fully. And also on the Hadley model, it's one of the best models for this we have found. So the weights we give to the Hadley, it's always more significant. So I didn't mean to imply anything. I just mentioned that it's good practice to use, to look at other models because they all have something to offer. And the issue is how to extract this information from them.
Okay, we are running late, so last question, and then we have coffee.
If you find some.
If you find Okay, Greek coffee.
It's the French one.
Short question, please.
It's Dr. Mohamed Sharawi, Minister of Water Resources in Egypt. It's very interesting talking on a scientific manner. I mean, that this discussion can go for hours and hours. The idea is that, we mentioned that cooperation is important, but we mean that cooperation between the countries and the regional and international level. So we don't talk about the cooperation of scientists, because scientists should deliver some kind of unified systems that the countries can cooperate based on. The idea is that we are still negotiating which better GCM model or the results or based on data and so forth. And I mean that the base of the scientists or science and technology working in the climate change is a little bit advanced than what is the political or country level decision making is. So unless we convince the countries that can lead a unified or cooperation decision based on one that they can accept, one model rather than they can all accept. So this is an issue. Unless we in the science community achieve something that we don't debate on as a scientist because I'm a country, bring my experts, and another country bring their experts, and we discuss. And we will never get an agreement. So this is, I think that this is an issue that we should think about, and we should also in this community, rather than going to other stakeholders at different levels, that we should send some key messages that at least we all know that there will be an impact, and we should move by any means, even though we don't exactly know the exact impact. If it's 2 degrees, 2.5, 3 degrees, we should have an action right now.
It's not only the atmospheric models. It's about a whole suite of models that have to be brought to bear to do this kind of analysis. What you said is so important. I mean, I cannot say enough about this. If there's not any trust to the scientific information that's provided and informs the political process of negotiating agreement, there will not be any agreement. I can guarantee you this. Because who is going to trust if later on, when something doesn't work the way people want or policymakers want, they will say, no, your data is wrong. So there has to be agreement, there has to be buy-in, there has to be ownership of the data, of the models, understanding, and so therefore this question of scientific cooperation has to, it's a paramount of paramount importance. I think it has to happen, but it's a process, it's a political process that has to impose this. I mean, we cannot, the scientists or anybody who is here, on our own accord, go and demand that we participate in the discussions and inform the political process. It has to be that it's done in the right way, and I think it falls on the lap of the policymakers, the ministers who actually drive this process. That's how I see it. Yeah, but you're right.
We're running late, so I think we'll stop now, and we thank all the presenters, and we thank you all for being with us. Thank you. Thanks a lot.